Okay, let's pick back up, back where I made the mistake, and hopefully we can figure this thing out. So we had a -7 and a +12. That gives me these two together give me a +5. 5 minus 3 1/4. That's going to be a little bit more difficult. So I'm going to do this. 5 over 1 minus 3 1/4. So I need to make this into an improper fraction. So I multiply and add. 3 times 4 is 12, plus 1 is 13, so that's 13/4. Well, I have to have a common denominator. So what number does 1 and 4 go into? 4. So I multiply the top and bottom of my fraction by 4. 5 times 4 gives me 20 over 4 minus 13/4. That gives me 7/4. Okay, now this is making a little bit more sense. So now everything inside the brackets, everything inside here is equal to 7/4. So now I just got to multiply by 5/8. So 5/8 times, you can write it like this. You don't have to use parentheses. Parentheses, you'll come to learn, mean multiplication whenever there's something outside of it, usually. So we just got to multiply by 7/4. And we just multiply straight across. 5 times 7, 35. 8 times 4, 32. Well, how many times does 32 go into 35? Well, it goes in one time. Once I take 32 out of 35, 35 minus 32 leaves me 30 seconds. So that was actually ended up being a lot easier than I made it out to be when I was making mistakes. It was a lot easier problem. Okay? So a lot of this stuff you got to think back on what you've already learned. How am I going to make this a little bit simpler on myself? Well, again, adding and subtracting, you have to have a common denominator. Multiplying and dividing, you do not need a common denominator. Okay, and remember, dividing is just like multiplying, except you keep, change, flip. So, and then it just becomes multiplication again. Let's move to number 12. Tino bought a piece of granite that is 5.5 feet long. The cost of the granite is $3.50 per foot, including tax. What is the total cost in dollars of Tino's granite purchase? Okay, we have some numbers and they gave us some information. Including tax, that means tax is in the money. That means I don't have to worry about it. Okay, if it says add tax or find the tax, then I got to worry about it. This one, I don't have to worry about it because tax is included in all my pricing. I don't care about it. They give us a couple of numbers. We got 5.5 feet and we've got $3.50. Is there a clue as to how they want their answer? Well, yeah, they want it in dollars. Well, how are dollars? Are dollars in fractions? No. Are dollars in percents? No. Dollars are in decimals. Okay, and it's pretty obvious right here when you've got a big, huge red, $19.25. But let me show you how we get it. Well, that means if our answer's got to be in decimal, that means everything we work with should be in decimal. Well, how do I turn 5.5 into a decimal? What's $5.50? That's pretty simple. 5.5. And we already have the 3.5. And you can put the 0 if you want. It doesn't matter. I'll tell you what, if there's a 0 at the end, it's just going to add a line of zeros to your multiplication because you're going to have to do long multiplication on this. They're probably not going to allow you to use a calculator on this problem. So if there's a 0 as your last number and you got to multiply, just get rid of it. You don't need to have it. This is really a lot simpler if you just do 5.5 times 3.5, and all I'm doing is lining up the last number of what actually matters. So I lined up the 5s, the last numbers, and then we multiply. 5 times 5 is 25, carry the 2, put down the 5, carry the 2. 5 times 5 again is 25, plus 2 is 27. Put a 0, because every time I go down there, I got to add a 0 and move everything over 1. 3 times 5 is 15. Put down the 5, carry the 1. 3 times 5 again is 15, plus 1 is 16. Then I just add straight down. 5 plus 0, 5. 7 plus 5 is 12. Carry the 1. 1 plus 2 is 3, plus 6 is 9. 1, bring that down. Okay, I got 1,925. Is that right? No. Then I count. How many numbers do I have after the decimal in the numbers I multiplied? There are 2 numbers to the right of the decimal in the numbers I multiplied. There's a 5 and another 5. It doesn't matter what the number is. Just matters how many digits I have. Well, there's 2 digits. So that means I move over 2. So my decimal goes there. So I got to make sure there's 2 digits to the right of my decimal. And there is my answer. Matches $19.25. So a lot of these, they give away how they want their answer. So if they want their answer in decimal, that probably tells you I better put everything in decimal form. That's the easiest way to get my decimal answer, right? So don't try to do 5.5 times 3.5. You'll drive yourself nuts trying to do it. Let's go down here. Select all the expressions that equal -11 minus -2. Now, a minute ago I said, basically whenever you see parentheses, it means multiplication. And that is true. The way you would look at this problem, there's 2 ways you can look at it. You can look at it the really simplistic way, where you're saying, okay, I've got a -11 minus -2. So I'm taking away bad. Okay, so that becomes -11 plus 2. Well, guess what? That's A. Let's look at it a different way. Let's look at it the way I said, parentheses always mean multiplication. Well, that little negative right there in front of the parentheses. And when I say front, that means if you're reading normally left to right, that negative comes before you get to the parentheses, right? So it's in front. That really means a -1. You can look at it this way too. And that -1, oops, let me put it back. That -1, if I multiply a negative times a negative, what do I get? Negative times a negative gives me a positive. 1 times 2 gives me a 2. This -11 stays there. Guess what? I get the exact same thing. Exact same thing. Now, if I look at all these answers, this is the only one that's actually a -11 plus 2. This is a +11, so that right there, that one gets rid of that one. This is also a +11. If there's nothing in front of the number, then it's a positive. This one has a -11, but it also has a -2. Adding a -2 is the same as -11 minus 2. So that one doesn't work. Only A is the correct answer. Okay, we've got 3 more problems to get through. What is the value of 5.2 minus -4 plus 0.6? This one could be kind of hard, but remember, a negative and a negative in line, you could think of it either way. I could say that's a -1 times a -4. So it's really 5.2 plus 4 plus, but this positive, I don't really need these parentheses because it's like a +1 times everything, which is just, +1 doesn't change the value of anything. So I get that. The simplest way to deal with this is add it. Vertically add 5.2. I've got this 4. I need to have a decimal. 4.0. Okay? I got to line up all my decimals and just add down. Okay, see what I did? So really I had 5.2 plus 4.0. You can do that. 4.0 is the same as 4 plus 0.6. And I just lined up my decimals, and I'm going to add down. 2 plus 6, 8. 5 plus 4, 9. My decimal comes straight down. That's how they get 9.8. Okay? It's not terribly difficult once you really think about how would you normally do these problems. There's a lot of different ways to go after them. What is the value? Well, let's look at it. And I'm going to go over this 2 different ways. One, I'm just going to go at it the normal way. This is all multiplication, right? Put a little dot, that means multiply. Well, a negative times a positive times a positive. How many negatives you see? 1. Is 1 even or odd? It's odd. So that means my answer has to be a negative. So now we can forget about the negative. We know our answer's got to be negative. Then I can do all of this stuff. Now, I could go ahead and do 5 times 32 times 1 over 5. let's go ahead and do that. I'm going to show you something. I need to write all these as fractions, though. I'm going to write them over here. 5 over 1 times 32 over 1 times 1 over 5. So I just made this into a fraction, this into a fraction. I'm just multiplying straight across. Now, I'm looking to reduce anything I can. Now, if I look at 5 over 1, can I reduce that? No. 32 over 1, can I reduce that? No. 1 over 5, can I reduce that? No. I can't reduce those, but I can cross-reduce, and that's going to make our life a lot simpler. And when I cross-reduce, that means I can look at this 5 and compare it to any denominator. I can look at any one numerator and compare it to any denominator. Well, guess what? I see a 5 in the numerator and a 5 in the denominator, right? So guess what those do? Those cancel or reduce. 5 goes into 5 one time, 5 goes into 5 one time. Can I reduce anything else? No, there's nothing else to reduce because all I've got left is 1s. So if I multiply straight across, 1 times 32 times 1, 32. 1 times 1 times 1 is 1. And remember, our answer over here was going to be negative. So we end up with negative 32 over, 32 over 1, or just negative 32. So that's where that comes from. Okay? A lot simpler when you break them down and start doing things like that, turning everything into fractions. You start to recognize, ooh, you know, I can reduce some stuff here. Okay? One last problem. This one probably stumped a lot of you. Let's go ahead and make it all into fractions. We could just multiply. If you really look at this stuff, you start to see patterns, and you're probably not to that point yet where you can see patterns. But you start comparing all the different things, because it doesn't matter what order we multiply these things. But it starts to come together for you sometimes when you look at these and go, wait a minute, some of this stuff can reduce into like 1. So let's look at something. I want to look at just take a look at these numbers. I've got 100. I've got 10. Those are my whole numbers. Then I got some decimal numbers. 1/1000th, 1/10th. Now, I can look at this a couple of ways. First of all, I'm thinking about, now they're saying what is the value of this, and obviously they've got decimals, so they probably want this in decimal form. I can think about this in fraction form, and let's just look at it that way real quick. 100 over 1. This is going to end up, this is tens, hundreds, thousands, so that's 1/1000th. This is just, the next one is just 10 over 1, 10 over 1. And then this last one is 1/10, a negative 1/10. Okay? So if we look at that as fractions, there's some stuff I can cancel. 10 and 10, 10 goes into 10 once, 10 goes into 10 once. 100 and 1,000, well, 10 goes into both of those, right? 10 goes into 100 10 times. 10 goes into 1,000. Actually, let's do something even a little bit bigger. 100. 100 goes into 100 one time. 100 goes into 1,000 10 times. Wow. Doesn't that look a lot simpler? I've got rid of all the big numbers. Now all I got is ones. Because I got 1 times 1 times 1 times negative 1. That gives me negative 1. 1 times 10 times 1 times 1 is 10. Negative 1/10. How do I write that as a decimal? Negative 0.1, or 1/10. Another way I can look at this is, let me clean this up a little bit. This is a tenth. 1/10. What's 1/10 of 10? If I divide 10 by 10, I get 1. So these two things together just give me a negative 1. 1,000th of 100. Well, that's kind of hard. if I multiply, let's go ahead and multiply 100, and we don't have to line anything up, but we got 0.001. Let's try that. 1 times 0 is 0, 1 times 0 is 0, 1 times 1 is 1. And then we got 0, 0, 0, 0, 0, 0, and then we got to add down. 0, 0, 1, 0, 0, and we look 1, 2, 3 digits to the right. So that's what I get when I multiply these two. I get 0.1, really. Or you could say 0.100 or 0.1. Because really this 0 means nothing, and these two zeros don't really mean anything. So I got 0.1. Well, what's 0.1 times a negative 1? Well, what's 0.1 times a positive 1? It's just 0.1. If I multiply it times a negative 1, I get negative 0.1. So that's how they get their answer. There's two ways to do it. In a problem like this, you can attack it either way. Turn them into fractions. As long as you understand how to say a fraction, you can write it as a decimal. 1/10 is, or negative 1/10 is 1/10. That's what it is, or 100th, or 2,000ths. You got to be able to understand how that writes it as a decimal. So that's actually a really simple problem. It just looks really complicated. Trying to think of another way to even do that would make it even simpler. Let me show you another way. This is going to be the last way I'm going to do this, and then we'll be done, and you can do Prodigy after you've done this. Let's do 100 times 10. That gives me 1,000. Now, I don't need to multiply these other two numbers together yet, but guess what? This is 1 1,000th. What's 1,000 over 1? That was the 100 times 10, times 1 1,000th. That's this, right? Tens, hundreds, thousands. 1 1,000th. Guess what? Those cross reduce. That's a 1, that's a 1. That gives me 1 over 1. So now all of this right here equals 1. This all, equals 1. 1 times a negative, times this negative 0.1, 1 times a negative 0.1, well, it's just negative 0.1. That's an even simpler way to do it. Okay, you don't have to multiply in order. If everything's being multiplied, you can change the order. Okay, it doesn't work so much for division, but multiplication, you can move things around. If everything's being multiplied, it doesn't matter what order you multiply them in. Okay, so that is the last problem. Hopefully this makes some sense and helps you out on this CASP test, or this IAB we're taking tomorrow. Please make sure you pay attention to this. If you want, go home, watch this video again. It will definitely help you on this test tomorrow, because these are basically the same types of problems you should be seeing on the test tomorrow. Okay, and that is it for today.